Alright, let's look at the practice exam 3, problem number 6. Alright, so let's find the antiderivative of this guy. Alright, so first thing is that, let's see, antiderivative of 1 is x. So that's easy, right? And the 1/2 is just a constant multiple, so I'll just put that in front. Antiderivative of 1 over x is natural log of absolute value of x. Right? Don't forget to put the absolute value sign there. Alright, then we have, if you take the antiderivative of e to the negative 3x. Alright, so this is one of the tricks. When you have, let's see, integral of, say, e to the ax plus b. Right, so this is only this only works when you have a linear function inside. Right? Then all you have to do is write down the same exponential function and divide by the derivative of this guy. So since it's an antiderivative, normally chain rule is you multiply by the derivative of the inside function. But since it's the antiderivative, we're going to divide by the derivative inside. So in this case, derivative of that is a. Right? But this only works when you have a linear function. Right? So this is going to be always a number. Right, plus some constant c. Right, and the same thing, if you want to integrate, for example, cosine of ax plus b. Right, so let's do a trig function. Right, so antiderivative of cosine would be sine. Right, so you have a sine of ax plus b, but we have to divide by derivative inside, which is a, plus some constant c. Alright, so let's use that to save some time. Alright, so you have e to the a in this case is negative 3x. So you just write down exactly the same thing and then divide through by negative 3. Alright, so if you want, we can actually, so I'm going to just change that to negative sign. Alright, so let's go ahead and do that so we don't have to write two lines. Alright, the next one, same thing we have. Alright, secant tangent, antiderivative is secant, so I'm going to write secant here. So secant of 4x. Right, so we need to divide through by 4, so I'm going to put 1 over 4 here. Right, then you have plus some constant c. Right, so that's the antiderivative that we're looking for. Right? You could use substitution here, but it's much quicker to do it this way. All right? Let's look at part B. All right? So we did this in class, but here, all right, put 3 in front, and then I'm going to also pull 4 out from the denominator. So we're going to get the integral from 1 of 1 over, right? So x squared plus 9 over 4 dx. To make it look like the hint here, I'm gonna just keep 3/4 in front, and then I'm gonna write 1 over, right? So x squared plus, right? In this case, 9 over 4 is same thing as 3 over 2 squared dx. Right? So in this case, a is equal to 3/2. Right? So I'm going to just apply the formula here. 1 over a, so it's a reciprocal of 3/2, so it will be 2/3. Right? Then you have arctangent. Right? Then you have x over a, which is 2x over 3 plus some constant c. Right? So this is the antiderivative that we were looking for. Alright, that's it. I hope that this was clear.